During the early Apollo years, NASA scientists and engineers anticipated the need for a vehicle to aid the astronauts in exploring the moon. It was expected that bulky spacesuits, limited life supplies, and other inherent weaknesses would decrease man's mobility on the lunar surface. In 1964, with conceptual design of the Mobile Laboratory, or MOLAB, NASA began research on lunar surface vehicles. Over the next few years, an entire spectrum of vehicles was designed and studied. From these efforts came the knowledge that contributed directly to the development of the Lunar Roving vehicle. Its development required solution of many challenging technical problems for which there were no precedents in terrestrial vehicle design and operation. For example, the lack of an atmosphere on the moon, the extremes of surface temperatures, plus or minus 250 degrees Fahrenheit, the very weak gravity, 1/6 of Earth's, and the many unknowns associated with the lunar soil and topography. All these factors imposed severe and unique requirements on the LRV. The first manned landing on the moon, Apollo 11, and subsequent missions confirmed the long-recognized need for a lunar vehicle, a vehicle which would allow astronauts to cover more area, to conserve energy and life support materials, to transport additional equipment, and to return with more lunar soil samples. For even before these practical demonstrations, in May of 1969, NASA decided to proceed with the design and development of a lunar roving vehicle. The Marshall Space Flight Center at Huntsville, Alabama, where the Saturn V moon rocket had been developed, was assigned overall direction of the LRV program. Prime contractor was the Boeing Company, using facilities at Huntsville and Kent, Washington. Major subcontractor was GM's Delco Electronics Division in California. The LRV would be a two-man, four-wheeled vehicle, 10 feet 2 inches long, 44 inches high, with a 7.5-foot wheelbase, weighing 460 pounds earth weight, and capable of carrying a total payload of 1,080 pounds. The LRV would have 5 major systems: mobility, crew station, navigation, power, and thermal control. The mobility system, which must be able to cross 12-inch high obstacles and 28-inch diameter craters, consists of the wheels, traction drive, suspension, steering, and drive control electronics. The system was designed, developed, and tested by General Motors. The first assemblies were put through development tests to measure strength, deflection, endurance, and other factors. For example, driven on a rolling road fixture, the wheel assembly was tested under Earth conditions, and later in test chambers reproducing the environmental conditions of the moon. The LRV tires are made of a woven mesh of zinc-coated piano wire, to which titanium threads are riveted in a chevron pattern to keep the wheels from sinking into the soft lunar soil. Long-duration torture testing on this so-called carousel, simulating the lunar surface, verified the durability of the wheel design. The test assembly was supported by springs to relieve most of its weight, thus simulating the 1/6 gravity of the moon. A mobility test unit was used in early phases of development to validate the LRV mobility system. The astronauts participated, as they did in all aspects of LRV development. 2 36-volt silver zinc batteries provide the vehicle's power. Each wheel is individually powered by a 1/4 horsepower electric motor. A highly efficient harmonic drive system, originally developed by the U.S. Shoe Machinery Corporation for other purposes, is used with each motor, eliminating the need for a transmission and its gears. The suspension consists of a damper or shock absorber supported by triangular arms that pass the suspension loads to torsion bars. Other systems were also being developed. For example, a simple navigation system, which would allow astronauts to drive beyond sight of a lunar module and yet be able to return to it by the most direct route. The system works by recording direction and distance traveled from a starting point. In order to assure the proper physical relationship or interface between the vehicle and the astronauts in their pressurized spacesuits, several so-called crew station reviews were conducted, first in normal Earth gravity conditions and later in simulated 1/6 G. The LRV's crew station consists of the control and display console, seats and seat belts, armrests, footrests, hand and toe holds, floor panels, and fenders. For other crew station reviews and development testing, an LRV mock-up was installed in a KC-135 aircraft which flew parabolic flight paths. This provided brief periods of low gravity, simulating lunar conditions. One example of interface problems was the initial difficulty in getting onto and off of the LRV. Addition of a simple toe hold plus astronaut training proved to be the solution. Another interface problem was the design of control switches, which could be easily manipulated by a gloved hand. Similar problems were involved in operation of the uniquely designed hand controller located between the two astronauts, which provides steering, speed, and banking commands to the vehicle's drive control, electronics, and mechanical brake system. A major milestone in the Lunar Roving Vehicle Development Program was delivery by General Motors of the 1G trainer vehicle to be used for astronaut training. Though heavier and stronger than an actual moon rover, since the crew and equipment weigh 6 times more on Earth, the trainer was practically identical in size, shape, and handling characteristics. One simple difference was the use of ordinary pneumatic rubber tires because of the extra weight of the vehicle. At the Manned Spacecraft Center, the 1G trainer was operated using counterbalance springs to simulate the moon's gravitational field. Through operation of the trainer in this mode, astronauts were able to become accustomed to the LRV months before actual use during their mission. Storage and deployment of the vehicle provided major design challenges. As shown here by this special test unit built to equal on Earth the LRV's lunar weight, the vehicle had to fit within the tight wedge-shaped confines of one small section of the lunar module, about the volume contained in a family station wagon. Conversely, on the moon, the LRV has to essentially unfold itself by means of springs and deploy to the lunar surface locked in its operating configuration, all with minimum assistance from the astronauts. Further deployment tests were conducted using a full-weight LRV called a qualification test unit. The vehicle was deployed from a lunar module mock-up at the Grumman Aircraft Company, contractor for the lunar modules. During these tests, technicians manually assisted the vehicle throughout the procedure, since the deployment mechanisms were designed for the moon's weaker gravity and could not overcome the stronger gravity of the Earth. The main purpose of the qualification test unit was to make absolutely sure that nothing had been overlooked in terms of clearances and hardware operation. Manufacturing of the first flight LRV proceeded concurrently with the rigorous testing of non-flight units. As evidenced in this wheel fabrication, skilled and detailed handcrafting was involved in many of the LRV components. Early in 1971, production and testing of the first flight LRV neared completion. Vibration tests were conducted with the vehicle in both the folded and unfolded modes to determine critical frequencies. Other acceptance tests checked and rechecked every facet of the vehicle. The first flight model LRV was formally delivered to NASA by the prime contractor, Boeing, on March 10, 1971. 2 weeks ahead of schedule. It had been less than 18 months since inception of the LRV program, only 13 months since the prime contract was awarded, an accomplishment reflecting the outstanding effort and dedication of the joint NASA Industry Development Team. After government acceptance of the vehicle, it was folded, covered, and crated for shipment to the Kennedy Space Center. After delivery to KSC, the vehicle was unfolded and completely checked out again, and another crew station review was conducted. The LRV was then folded for the final time and installed in its flight position inside the lunar module of the Apollo 15 spacecraft, several months before launch. The LRV had received its final go, while the rest of the Apollo and the Saturn V launch vehicle would undergo further checkouts. Then the entire Saturn Apollo vehicle was moved aboard the giant transporter from the vehicle assembly building 3.5 miles to the launch pad, where it would undergo constant check and recheck right up until launch date. On July 26, 1971, Apollo 15, carrying the first lunar roving vehicle aboard, was successfully launched. After a 3-day translunar coast, the landing site was spotted, the rugged Hadley Apennine region, a potentially hazardous but scientifically interesting area of the moon.
15 at 1. -1. -1. 6% fuel. 10 feet, -1. 8 feet, -1. Contact.
The landing was successfully achieved. Apollo 15 Commander David Scott became the 7th man to set foot on the moon, with live color TV coverage beamed back to Earth. Lunar Module pilot James Irwin followed soon afterward, and they set about deploying the lunar roving vehicle for their first drive over the lunar surface.
Looks like she's coming down okay. Hey, can you pull it out a little bit, Jim? About. That looks good.
With minor difficulty, deployment and setup were successfully accomplished in 26 minutes. During initial checkout of the LRV, astronaut Scott discovered that the front steering mechanism was inoperable. However, the first lunar traverse of a Scheduled 3 proceeded satisfactorily, using only rear-wheel steering. Before the second traverse, the astronauts and LRV specialists on the ground succeeded in freeing the front steering mechanism.
You know what I bet you did last night, Joe? You let some of those Marshall guys come up here and fix it, didn't you? It works, Dave? Yes, sir. It's working, my friend. Beautiful.
In overall performance, the LRV more than met its standards. During a total of 3 hours and 2 minutes of stop-and-go driving on the moon, the vehicle traveled a total of 25 kilometers, about 15 statute miles. Astronauts Scott and Irwin covered almost 4 times as much lunar terrain as the total covered by the crews of the Apollo 11, 12, and 14 missions before them. The lunar soil proved much less troublesome than expected, with the LRV wheel treads leaving tracks only about half an inch deep. The suspension system worked extremely well, the astronauts reported, keeping the vehicle very stable, even on several rather sharp turns to avoid lunar obstacles. Average speed was 9 kilometers, about 6 miles per hour, more than 1 mile an hour faster than planned. The energy usage rate was much less than expected, only about 52 amp hours, compared to anticipated usage of 102. The vehicle still had about 80 kilometers of driving capability remaining when it was parked after the final traverse. The navigation system performed well, averaging a missed distance of only 1/10 of 1 kilometer upon return to the lunar module after each traverse. All in all, the lunar roving vehicle proved to be, in the words of astronaut Scott, about as optimum as you can build. After almost 67 hours on the moon, Scott and Irwin re-entered the lunar module with their collection of scientific samples for their return to Earth. Their liftoff in the ascent stage was photographed by the remote-controlled television camera left behind on the LRV. A spacecraft with wheels, the lunar roving vehicle has proven itself invaluable in extending man's ability to explore the moon.